In the system of linear equations above, a is a constant. If the system has no solution, what is the value of a? You need to remember when we have two linear equations here, and these graphs are not going to represent these. I'm just drawing two general lines. Let's say the first one is this. Any other line I draw will have one solution. In other words, one place where they intersect. Except for one line. If I draw a line parallel, they're never going to intersect, and that's when you've got no solution. So what I need to find here is what is the value of a that will make these lines parallel to one another. So how do I do that? Well, what I need to do is get this top equation to have a y coefficient of 3. And then I want to see what is this coefficient when I do that, and then what would a have to be to equal that. Because if I can get this and this to equal, and this to equal, we're going to have two parallel lines. So let's take 1/2 x minus 1/4 y equaling 5. And I want to get this coefficient to look like 3. So what do I have to multiply this to get 3? Well, 4 times 1/4 is 1, so 12 times 1/4 is 3. So let's multiply both sides by 12. So 12 times 1/2 is 6x minus 3y equals 60. Now my other equation is ax minus 3y equals 20. And so what does a have to be? Well, a has to be 6. Because then the x coefficient and y coefficient will be the same, which means when you put this in the y equals mx plus b form, you're going to have the same slope, which means if they've got the same slope, they're parallel, which means they'll never intersect, which means they've got no solution. So this one is choice C. A tough question here. They've definitely taken systems of equations more into what you would do in math class, and you have to remember, as we saw in the first part of this video, when a system of equations has no solutions, when it has one, and when it has an infinite number of solutions, which is a different type of question. Now, in this one, again, we don't have a graph, so we can't graph these. The key, as we saw, is to see that ultimately we want these coefficients to be the same, and that gives us no solutions. So that's tough. I mean, you may not remember that. You may have to relearn it, maybe even learn it for the first time. So again, it's one of these situations that if you know the trick, it's not that bad. If you don't, it could be a real pain. So this is, I think, taking lines and linear equations into a new realm, into a realm maybe you're used to in school, but certainly not one that was tested in the original SAT.